Welcome back to Hash and Verse. Today, we are diving deep into the engine room of modern AI. We're talking about fine-tuning large language models. If you've ever wondered how to take a generic model like GPT-4 or Llama 3 and turn it into a specialized expert for your specific needs, you are in the right place. We are currently witnessing a massive evolution in AI. Models like Palm and Llama are incredible. They can write code, answer questions, and generate human-like text. But here's the catch. They are jack of all trades. They often lack deep domain knowledge, or they simply don't sound like your brand. This is where fine-tuning comes in. Think of pre-training as teaching a model to read and write, while fine-tuning is sending that model to medical school or law school. It allows developers to adapt general-purpose models to specialized tasks, unlocking their full potential. So, when should you actually do this? You don't always need to. But if you are working in a niche field like legal analysis or medical diagnosis, you need the model to understand specific jargon. Maybe you need a specific output style, like a formal report versus a casual chat, or you need to fix performance gaps where standard prompt engineering just isn't cutting it. Now, let's look at how we do it. The traditional method is full fine-tuning. This updates all the parameters in the model. It is highly effective but computationally expensive. It requires a lot of hardware, and if your dataset is small, you risk overfitting, where the model memorizes the data rather than learning from it. To solve the cost issue, we use PFT, or parameter-efficient fine-tuning. This is a game changer. Instead of retraining the whole model, we use techniques like LoRa, low-rank adaptation. This freezes the original model and only trains tiny, injected matrices. It's faster, uses less memory, and keeps the original knowledge intact. Two other critical techniques are instruction tuning and RLHF. Instruction tuning trains the model on specific input-output pairs. This helps the model understand user intent. RLHF, or reinforcement learning from human feedback, creates that polished, conversational feel we see in ChatGPT by scoring the model based on human preferences. But a model is only as good as its data. For best practices, always prioritize quality over quantity. Curate focused datasets, clean out the noise, and use an 80-20 split for training and validation. When it comes to hyperparameters, start with a low learning rate to avoid overriding what the model already knows, and keep your epochs between 3 and 5. Finally, don't fly blind. Evaluate your model using metrics like F1, score, or BLU, but also use human testing. And crucially, consider the ethics. Audit your model for bias and ensure you aren't training on sensitive, non-anonymized data. Fine-tuning bridges the gap between generic AI and tailored solutions. Whether you are building a customer service bot or a research assistant, techniques like LoRa and RLHF are your best friends. Start small, iterate often, and let your data guide the way. Thanks for watching, and be sure to check out the full blog on Hash and Verse.